2. Good job. All right, so when we look at the goal that we're going to solve this question, we are going to try to find x. You are correct. We're going to cube the left and the right side of the equation. The cube root and the cube power cancel. 3 times 3 is 9, times 3 is 27. Does the cube root of 27 indeed produce a 3? If you go to Math 4 and take the cube root of 27, sure enough, 3 times 3 times 3 is 27. So your answer is here, but because on some of these, not this particular one, but some of them will make extraneous solutions, you need to do your check step. Now, how would we attack this one first, Madeline? What would you have to do? Right. Now this time, why are we saying add 9, where when Tate a minute ago said, let's subtract 7, I said no. What's the difference in example 1 and example 2? Right. The second one is outside the radical. So let's add 9. We have now isolated the radical. How would you undo a cube root, Chloe? Exponent of what? Good. She said she's going to do the exponent of 3. The cube root and the cube power, opposite operations, they undo each other. And 8 times 8 times 8, 512. It's huge. So the cube root of 512, I have to check it. Is indeed 8. 8 minus 9, does that equal negative 1? And it does. You think, oh my gosh, this is not so bad, and then all of a sudden, dun, 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 we get something ugly like that. All of a sudden, it looks difficult. But is it difficult? Good, Harrison. So I would convert from exponential to radical form and say, well, that's just the square root of x. Now it looks very similar to example 2. What would you do first to both sides, Karaya? Perfect. So I now have the square root of x equals 8. And Blake, what would you do to get rid of the square root? Yes, so how am I going to get the square root to cancel? Power it. She said multiply, but it's the power of 2. So be careful. I think she was thinking right. And 8 times 8 is 64. When you check it, you've got 64 to the 1/2 power minus 3 equals 5. Is the square root of 64 doable? Yes, it's 8. And does 5 equal 5? And that is a yes. All right. This time we have 1/2 times the radical, 3x minus 2 equals 3. Remember, we're always going to isolate the radical first, if possible. So can we isolate that radical? How could I get rid of times 1/2? Or multiply by what? Its reciprocal, which is 2, or 2 over 1. So half of 2 is 1, those cancel. So I have the square root of 3x minus 2 equals 6. Now, Erica, how could I get rid of this square root so that I can solve the rest of it? Take it to the power of 2 on the left and the right. The opposite operations cancel. So you have 38 thirds or 12 and 2/3 or 12.7. If you cannot check it with the decimal that's been rounded, do you know why? Why, Selena? Right, and then you're going to not get back to the true statement in the check step. So don't use your rounded decimal. I'm going to use the improper fraction because by looking at the problem, I can see that the 3 here is going to cancel with the denominator. So that's why I'm using the improper fraction versus the mixed number. So in this step, when I go inside the radical, the 3's cancel. I have 38 minus 2 equals 3, question mark. What is half of the square root of 36? That is a 2. And Harrison's right, half of the square root of 36, which was 6, is 3, and it is true. So our answer is correct. You can write it any of these forms, but when you check it, do not use a rounded decimal because it could make it come out to not be equal when it really is. Solve. Each one of these is a solve, which means we've got to get x by itself. My first question is 3/2 power on x and 3 or just x? What do you think, Dylan? Is the 3/2? Okay. Now, that means I need to isolate this x. So, Keandre, how would I isolate that? I want it by itself. Not yet. We'll do that in a second. He wants to convert to radical, which is fine. We'll do that in a minute. Go ahead, Tate. Yeah, it's times 3, so we're going to divide it by 3, and then in just a second, we're going to do what Keandre suggested. Keandre said, I want to look at it as the square root of x to the third equals 125. And that is going from exponential to radical form. So let's attack it the first way, method 1, one piece at a time. First, how do you get rid of the square root? Hannah R., how do you get rid of the square root? So that's the first thing I'm going to do. I'm going to square it. So that's going to get rid of just the radical, and I have 125 times 125, which is a pretty good number. Now, what am I going to do, Haley, to get rid of this third power? What's the opposite of that? Good. So we're going to use a root. Now, which root do we use? Good. Third root. So, because she undid the third power with the third root, she got x out. And then let's see if there is a cube root to this hideous 15,625. Here is. Good. 25. Much prettier. When we check this guy, we've got 3 times 25 to the 3/2. Does that equal 375? So remember that you can put 25 to the 3 halves in your calculator in one fell swoop. So 25 to the 3 halves is 125. So does 3 times 125 equal 375? Indeed it does. So it did work out. Okay?
Whenever you get to the square of x cubed equals 125,
The cube root? Oh, the square root, I see.
Square of
Mm-hmm.
x cubed,
Uh-huh.
would that cancel out to make it just like x? 'Cause
Okay, look what you have, Harrison. You have a square and a square root. What is canceling right now?
yeah, I understand that the square is canceling, but like, if it's the cube root of x, or the square root of x cubed, are you allowed to get rid of the radical because there's already
If you're doing the square root of x cubed only and there's no power of 2, then that would be what you would go to. But we have a power of 2 to deal with. But yes, if it was just the square root of x cubed, the square root of x squared is x, and then you'd have a leftover that was single. Yeah. Now, I want to show you method 2 in case you like it better. When you get to this step, x to the 3 halves equals 125. I would consider this a shortcut. I do not know how you will feel about it, though. Instead of changing from exponential to radical, how would you feel about taking both sides to the 2/3 power? Does that make any sense to you, that 3 halves to the 2/3 is going to multiply to be 6 over 6? Well, what's 6 divided by 6? 1. So does it make any sense that this would be shorter if you can figure out the fractional part of it? That all you would have to do is go straight to this little guy, 125 to the 2/3. In here we had we started with it and we had to do a squared, then a cube root, then the answer. Here we went straight from here to the 2/3 power to the answer, which cut out one step. So I don't know if you want to do it method 2 or method 1. Either one is okay with me. Just depends on which one you like. The radical is as isolated as it can get. How do I undo a square root? Square. So this side easily becomes 7x plus 15. The side I worry about is this side. Students will say this is x squared plus 1 9 times out of 10. That is not correct. It is x squared plus 1x plus 1x plus 1. So it really is x squared plus 2x plus 1. The mistake students make is they don't write this parenthesis twice. From there, we get everything on the same side of the equal, and then because it's a quadratic, you can do the quadratic factor, the quadratic equation, you can try to factor, but it has to be equal to 0 or y before you can do any of those things. Because a is 1, I would always try to factor this first because it would be faster. Do you know of anything that will multiply to be 6 and add to be negative 5, Britta?
Wait, you said there's 15 and then you subtract 15 and then how did you get 6? 1 minus 15.
I just made up some math.
Okay.
You know. It's because I acted like it was a 5. See?
Yeah.
I can't read my own writing. So now, is there anything that will multiply to be negative 15 and add to be negative 5? Let's do a redo.
Oh.
And you get a point for that.
Yes. Negative 14, 1, 7, and 2.
Good. That is a minus 15, guys, not a plus 5. Then, how do we solve it from there? What would you do, Spinda, to get the x by itself once you get down that far? Yeah, perfect. Most of you do not even write this step anymore. Most of you just change the signs right there, which is also fine. The only unfortunate thing about getting two solutions is what if you have to do twice. Yes, I heard it on that side. Check it twice. And the square root of 64 does equal 8. (15 minus 14 is 1). Does negative 1 equal 1? So what is the only answer we're keeping? What do you say when something happens like that? Good. It's an extraneous solution, and we have to toss it out. So negative 2 is out, and only 7 is in. Is there any way to isolate both radicals? If I subtract the 1 and put it on the other side, then didn't I just put it with another radical? All right. So the way we're going to attack this is right here from the beginning. We're going to square both sides. Here is where you have to be careful. Those easily are opposite operations. But this parentheses must be written twice. And this looks very odd, I'm sure, to all of you. The square root of x plus 2 plus 1 times the quantity square root of x plus 2 plus 1. Now, you can do FOIL, distributive, or the box. I'm probably going to do FOIL on this type of a problem. When I multiply that times that, I get the square root of x plus 2 squared. So what's going to happen to the square root and the square? Good. So I'm going to be left with x plus 2 for my first term. Then I do inside and outside. So outside would be square root of x plus 2, and the inside is going to be square root of x plus 2, and last times last is going to be a 1. So each piece of my FOIL gives me something for the final left side of the problem. So I have an x plus 2. I have 2 square root of x plus 2's plus a 1 equals 3 minus x. So all I did here was FOIL, but I FOILed something very strange. Something that I don't know that we've even looked at before. I'm going to subtract an x. I'm going to put my 2 and 1 together. Subtract a 3. And what I'm doing is I'm just working down the problem, trying to get back to where I can isolate the radical. I'm sorry, what? I would add the x on 3 minus x. No, I would subtract the x. I'm moving it from this side to this side. Not Hunter, Harrison. I was moving not this way, Hannah. I was moving this way. Where did I get that 3?
All the extra ones. So
I had a 2 here and a 1 here, so I added those to be 3, made a 0 pair out of it, which was nice because it zeroed it out on both sides. Now I want this radical by itself, Rob. What would I do? Good. So in this problem, you feel like you've gone backwards and forwards, and it's crazy. I finally have my radical isolated again. So Caitlin Hall, what would I do to get it out of the radical? Good. There should not be a parentheses there. And negative x times negative x is x squared. Move everything over there. X squared minus x minus 2. Is there anything I can multiply to be negative 2 and add to be negative 1? What do you think, Riley? Multiply to be negative 2, add to be negative 1. Good. So now that the problem has taken 3/4 of a piece of paper, what do we do last? Check it. So it looks to me like 2 is not a winner. Did y'all get 3 equals 1, which is false? Yes, no, or y'all just copying it down? Are y'all working it or copying?
Where'd you get the 2?
Which 2? There's 4 or 5 of them.
The first, whenever on the first check, the 2 plus 2.
Because it is square root of x plus 2. So what do I do with my first solution? Plug it in. So I'm kicking out x equals 2. Now I'm going to check negative 1 plus 2 outside the radical plus 1. Does that equal square root of 3 minus a negative 1? Square root of 1 plus 1, does that equal square root of 4? And yes, it does. So we'll keep x equals negative 1. So at first, in the first, I don't know, 3 or 4 examples, all the solutions worked. But then they stopped working.